So in this video, we're going to be factoring by greatest common factor and factoring by grouping. Now, when you factor something, and we're going to be factoring polynomials in this video, basically factoring is breaking stuff down into smaller pieces or simpler polynomials. And then when you multiply those polynomials together, you get your original polynomial. So it's kind of like prime factorization. Remember how we broke that down into individual numbers and we multiply them all together to give us the original number. Factoring polynomials works the same way. So when you factor by the greatest common factor, what you're going to do in the steps here, the first step is you're going to write the greatest common factor of whether it be 2 terms, 3 terms, or anything. In step 2, you're going to divide out of each term. And I should say divide out the greatest common factor of each term. So if we look at x squared and 5x, and you think about what's the greatest common factor of that, again, you look at the numbers in front. Well, there's no real number in front of the x squared, and there's a 5, so there's no real number we can divide out there. So to have a greatest common factor of 1. Okay, let's just put that 1 there. And then out of x squared and x, they have x's in common, so use the lower power, and that's going to be the x. So a 1x, or I don't even really need that 1. So just like that. So our x is our greatest common factor. Now what I want you to do is put parentheses down there, and it's kind of like you're undistributing. Okay, so think about x times what and x times what else will give me back that x squared plus 5x. And remember, when you're multiplying monomials, you just multiply the numbers in front and you multiply the terms together. So x times what will give me x squared? Just an x. And x times what will give me 5x? Just a 5. So x, and in parentheses, x plus 5 is the fully factored form. And basically, since we pulled out an x, basically you drop an x out of both of those. So the x squared become just the x, 5x just became a 5. Looking at a few more, I got 5m to the third and 45. What's the greatest common factor of those? That will be 5. And 5 times what and times what will give me back that 5m to the third plus 45. Well, I got m to the third, since 5 times m to the third will give me 5m to the third. And 5 times what will give me 45? And that'll be a 9. So 5 times m to the third plus 9. And here I have 3 terms. I have 15y to the third plus 20y to the fifth minus 10. What number can divide 15, 20, and 10? Okay, we'll use a 5. And I have a y to the third, y to the fifth, and nothing. So I can't actually include a variable on the outside. 5 times what will give me 15y to the third? That'll be a 3y to the third. So again, undistributed. 5 times what will give me 20y to the fifth? That'll be a 4y to the fifth. And 5 times what will give me a negative 10? That'll be a negative 2. So you can have negatives in these. So 5 times 3y to the third plus 4y to the fifth minus 2. And if you're ever unsure, you can always just distribute it and see if you get the same answer. So a few more. I got 10y squared plus 12y to the third. I can divide 2 out of both coefficients. I have a y squared and a y to the third. Use the lower power. Use the y squared. 2y squared times what will give me 10y squared? That'll be a 5. And 2y squared times what will give me 12y to the third? That'll be a 6 y. Okay, so remember, y squared and y will give me y to the third. So I have a negative 12t to the fifth plus 6t. Don't worry about the negative, just kind of pretend the negative isn't there for a sec. What can divide 12 and 6? Of course, that's 6. Looking at the t's, what's the lower power? Just a single t. 6t times what gives me negative 12t to the fifth? Well, 6 times negative 2 will give me that negative 12. And I brought one t out, so I need to have 4 t's, or t to the fourth, to get t to the fifth. And 6t times what will give me 6t? Okay, that's just a 1. Okay, it's not a 1t, because t times 6t will give me 6t squared. So always think about, when I multiply those, would that give me back that monomial? Looking at a few more here. I look at 6x to the fourth minus 15x to the third plus 3x squared. What can divide all three of these numbers? That'll be a 3. And I have x to the fourth, x to the third, x squared. The lowest one is that x squared. Okay, 3x squared times what will give me 6x to the fourth? That's going to be a 2x to the second. So the numbers in front, and then add the powers. And then minus a 5x. And plus 1. So 3x squared times 1. Anything times 1 is just itself. And the last of this kind here, I got 40, 16, and 8. I can actually divide 8 out of all three of those. And looking at the x's, what's the lowest power? That's x squared. Y to the third, y squared, and y. What's the lowest power? That'll be a y. 8 times what will give me 40? That'll be 5. I don't need any more x's, but I need a y squared, though, to give me that 3. To get 16x to the fourth y squared, I need a 2. How many more x's do I need? I need x squared, and I need a single y. And then a negative 1. You can think of it as a 1, but you don't really even need that 1. I have x squared. How many more do I need to get to 5? That'll be x to the third. And I have a y. I don't need any more to get to y. So just minus x to the third for that one.